Welcome to our deep dive into something, you might already think you know a lot about, your skeletal system.
It's more than meets the eye.
Yeah. We've got excerpts from a biology textbook and a medical website, and honestly, even I was surprised by some of this stuff. Did you know your bones are making hormones that impact your metabolism?
Yeah, it was wild.
Yeah, I'm serious. So get ready. Get ready to look at your skeleton in a whole new light. So, okay, the textbook starts off with the basics, defining the skeletal system as the framework of the body. As adults, we've got 206 of these amazing bones, and they're made of this dense connective tissue called collagen. And all that calcium we hear about, well, that and other minerals, that's what gives bones their strength. I kind of love this image of us, like as walking, talking protein sculptures.
Right.
Don't you?
It's a beautiful, beautiful way to think about it.
Yeah. But it gets even wilder. I mean, when you think about the fact that these sculptures are actually living dynamic structures.
Right. What's fascinating is that bones aren't just these static things. They have blood vessels, nerves, and they're constantly changing. They're constantly remodeling themselves throughout our lives. And this living aspect is super important for our overall health, which is something that the medical article really emphasizes.
Now, the textbook does this thing where it asks you to imagine what it would be like to live without a skeleton. And let me tell you, not a pretty picture. Would basically be giant blobs, unable to move, let alone stand up straight.
You'd be like a jellyfish.
Yeah, skin drooping over our eyes, forget seeing anything.
Yeah.
No bones, no selfies. That's what I'm taking away from this.
Yeah.
But seriously, it really makes you realize just how crucial our skeletons are.
Absolutely. It's easy to take them for granted, but they do so much more than just hold us up. They're giving us the shape, the structure we need to move, to interact with the world. Imagine trying to high-five someone without any bones in your hand. It wouldn't work.
Okay, so the textbook breaks down the skeleton into two main parts, the axial and appendicular. Honestly, I've always found those terms a little intimidating. Can you break that down?
Of course. So think of the axial skeleton like the central pillar of a building. It includes your skull, spine, and rib cage. It's all about that core support and protection. Then you have the appendicular skeleton. Picture it like the beams and supports that branch out from that central pillar. It includes your arms, legs, shoulders, and pelvis, all the parts that allow us to move and groove.
I love that analogy. It makes it so much easier to visualize. Speaking of protection, the textbook really emphasizes how our skeletons play this role in safeguarding our internal organs.
Yeah, definitely.
I mean, I know that skull protects the brain, but I never really thought about my rib cage as, like, a literal shield for my heart.
Yeah.
It kind of makes me want to take deeper breaths just knowing that.
It's remarkable, right?
Yeah.
But, the protective function is just one part of the story. Your skeletal system is also involved in this amazing process called hematopoiesis. Have you ever heard of that?
Hemata what? It sounds intense.
It's actually pretty straightforward. It's just a fancy word for blood cell production. And guess what? Your bones are playing a starring role in this whole production.
Great. My bones are making my blood. Seriously.
Seriously. Inside some of your bones, especially those flat ones like your pelvis, ribs, and vertebrae, there's this stuff called red bone marrow. Think of it as this bustling blood cell factory, churning out billions of red and white blood cells, platelets every single day. Red blood cells carry oxygen, white blood cells fight infections, platelets help with clotting.
Wow.
It's all happening thanks to your bone marrow.
Okay. That's officially mind-blowing.
Mhm.
And the medical article, it really emphasizes how important this blood-making function is for our overall health.
Right. And here's another amazing thing your bones are doing. They're acting like a mineral bank for your body, especially for calcium and phosphorus.
So like a vault for precious minerals. I'm intrigued.
Exactly. It's all about maintaining this delicate balance called mineral homeostasis. When our blood levels of calcium or phosphorus get low, our bones release those minerals into the bloodstream. And when levels are high, they absorb them back in, keeping everything in check.
So my bones are like master regulators, making sure my body has just the right amount of minerals at all times. Incredible.
It's a beautiful system.
Right.
But wait, there's more. This is where it gets really interesting. The textbook mentions that bones are an endocrine organ.
Hold on. Endocrine organ, like my bones are making hormones. Is that even possible?
It might sound surprising, but it's true. Bone cells produce a hormone called osteocalcin, and it's playing a vital role in regulating our blood sugar levels and how our bodies store fat.
Wow, this is blowing my mind. So my bones are impacting my metabolism too.
Yeah.
I had absolutely no idea. And speaking of impact, The medical article lists all these conditions and disorders that can affect the skeletal system. It's a pretty long list. Everything from arthritis and bursitis to osteoporosis and fractures. It really makes you realize just how important it is to take care of our bones.
You're absolutely right. We'll delve deeper into those conditions in the next part of our deep dive, but I think it's a good place to pause for now. What are your initial thoughts?
Honestly, I'm feeling a mix of awe and a little bit of, why didn't I know this before? It's incredible to realize just how complex and dynamic our skeletons are. There's so much more than just a bunch of bones holding us up. I'm definitely feeling inspired to take better care of my blood-making, mineral-storing, hormone-producing skeleton. Join us for part 2, where we'll explore even more fascinating aspects of this amazing system.
Welcome back to our skeletal deep dive. I'm
Yeah.
still reeling from all the amazing things we learned in the last part. Our bones making blood.
I know, right? Storing minerals,
Yeah.
even producing hormones. It's like our skeletons have been keeping all these secret superpowers hidden from us.
Right. It's mind-blowing when you start to realize how much is going on beneath the surface.
Yeah.
And speaking of things beneath the surface, we haven't even touched on all the different types of bones that make up our skeletal system.
You're right. The textbook mentioned all these different categories: long bones, short bones, flat bones, and irregular bones. But it kind of just glossed over what that all means.
Yeah.
Like, why all these different shapes and sizes? Is it just for looks?
Definitely not just for looks. It's all about function. Each type of bone is perfectly designed to do its job in the body. Take long bones, for instance. Think about the femur in your thigh. That's a classic long bone. It's long, slender, which gives it strength for support, but also allows for a wide range of motion.
So like a lever.
Exactly. Long bones are all about leverage and movement. They're what let us walk, run, kick a soccer ball, all those big, powerful movements.
Right.
And it's not just our legs. Think about the humerus in your upper arm. That's a long bone, too. Without that, we couldn't reach for things, throw a ball, or give someone a high five.
Okay, I was starting to see how form follows function here. What
Yeah.
about short bones? They always seem kind of, well, stubby to me.
They are, but that stubbiness has a purpose. Think about the bones in your wrists and ankles. Those are short bones. They're more compact and cube-shaped because their main job is stability and support, not so much those big sweeping movements.
So instead of livers, they're more like shock absorbers.
That's a great way to think about it. They help us absorb impacts and make those fine-tuned adjustments to our movements. Can you imagine typing on a keyboard or playing the piano without those small, stable bones in your hands?
Definitely not.
Yeah.
Okay, so we've got long bones for leverage, short bones for stability. What about those flat bones? The textbook mentioned the skull and ribs. Are they really flat? I mean, they seem kind of curved to me.
Flat is a bit of a simplification, but it's all relative, right? Compared to those long, slender bones, the skull and ribs are definitely flatter.
Right? And that shape is crucial for their function. Protection. The skull is like a helmet for our brains, and the ribs form a protective cage around our heart and lungs.
It's like our own personal suit of armor.
And not only that, those flat bones also provide a large surface area for muscles to attach to. Think about all the muscles that are connected to your ribs. Those muscles need a lot of space to anchor themselves so they can pull and expand your chest for breathing.
Okay, that makes sense. And then we have those irregular bones, the ones that don't seem to fit into any of the other categories. What's their deal?
Irregular bones are kind of the rebels of the skeletal system. They come in all sorts of unique shapes and sizes because their functions are so specialized. Think about the vertebrae in your spine. They have all those weird bumps and projections because they have to interlock with each other, support your spinal cord, and allow for a certain amount of movement.
So each vertebra is like a puzzle piece, fitting together to create this amazing flexible structure. Exactly. And then you have the bones in your face, which are also irregular. They have all these complex shapes to house our sensory organs, like our eyes, nose, and ears.
Wow, it's like every single bone in our body has a story to tell, and its shape is a clue to its function. I'm starting to see my skeleton in a whole new light.
I'm so glad. And remember, your skeletal system isn't just a random collection of bones. It's a beautifully designed, integrated system where each part works together to support, protect, and enable all the amazing things our bodies can do. Speaking of which, are you ready to dive into the world of joints?
They're kind of like the unsung heroes of movement, aren't they? You know, we've been focusing on bones this whole time, but without joints, our skeletons would just be, well, a bunch of bones.
Yeah.
Totally immobile.
Exactly. Joints are absolutely essential for mobility. They're the points where our bones connect, interact, allowing for that incredible range of motion we often take for granted. Can you imagine trying to walk or dance or even just, scratch your nose without any bendable joints?
Oh, it'd be impossible.
It would be impossible.
Definitely not a world I want to live in. So tell me, how do they actually work? The textbook mentioned all these different types of joints, each with its own, unique function.
That's right. Not all joints are created equal. Some prioritize stability, while others are all about flexibility.
Okay.
For example, let's talk about those fibrous joints, like the sutures in our skulls.
Yeah.
They're basically immovable, providing that rock-solid connection between the bones.
Wait, so those sutures, the ones that hold the bones of our skull together, they never move.
They don't.
That seems crazy. How do they stay so strong throughout our lives?
It is pretty amazing. They're incredibly strong, durable, because their main job is to protect our brains. Those bones need to be fused together to form a solid protective shell. It's like a natural helmet. Luckily for us, it doesn't crack as easily as a bike helmet.
Okay, that makes sense. We definitely wouldn't want any wiggling going on up there.
Right.
So those are like the super stable joints, right?
Yeah.
What about the ones that allow for more movement?
Well, then you have cartilaginous joints. Those are connected by cartilage, which is more flexible than fibrous tissue. Think about the intervertebral discs in your spine.
Oh, yeah.
They're made of cartilage.
So those discs are what allow our spines to bend and twist.
Exactly. They provide cushioning and flexibility, allowing us to move our spines in all sorts of ways while still maintaining, that essential core stability. Of course, there are limits. We can't all bend over backward like contortionists.
Yeah, good point. I'm happy with my normal range of spinal motion. Okay, so fibrous joints are for stability. Cartilaginous joints give us some flexibility. What about those joints that let us do things like, swing our arms around and dance the tango?
You're talking about synovial joints. They're the most common type of joint in our bodies, and they're all about movement. Smooth, effortless, and pain-free movement.
Okay, so synovial joints are the real movers and shakers of the joint world.
They are.
What makes them so special?
They have this incredible structure. Basically, the bones are separated by a fluid-filled cavity. It's called the synovial cavity. Think of it like a tiny water balloon between your bones.
Oh, wow.
And that fluid inside, that's called synovial fluid, and it's like a super slick lubricant reducing friction between the bones.
So it's like having tiny oil slicks inside our joints, keeping everything running smoothly. No wonder we can move so effortlessly most of the time.
That's a great analogy. And on top of that, synovial joints also have ligaments. They're these tough, fibrous bands that connect bone to bone, providing stability and preventing those bones from moving too far out of place.
So the synovial fluid keeps things moving smoothly. The ligaments keep everything in check. It's like a perfectly choreographed dance inside our joints.
It is.
The textbook mentioned that there are different types of synovial joints, too.
Yeah.
Each with its own unique movement capabilities.
Absolutely. Think about your elbow or your knee. Those are hinge joints. They're designed to move in one plane, kind of like a door hinge.
Okay.
They allow us to bend and straighten our limbs, but not to rotate them.
Okay, that makes sense. What about those joints that give us more freedom of movement, like in our shoulders and hips?
Those are ball and socket joints. They're the most mobile type of synovial joint. The rounded head of one bone fits snugly into a cup-shaped socket on the other bone, allowing for a wide range of motion in multiple directions. It's what allows us to swing our arms around, rotate our hips, and do all sorts of cool dance moves.
It's amazing how our bodies can do all these things without us even thinking about it.
It really is. And, we haven't even talked about pivot joints, like the one in your neck that lets you turn your head, or gliding joints in your wrists and ankles that allow for, those smooth sliding movements. It's a whole symphony of movement happening inside our bodies, thanks to all these different types of joints.
This has been such an incredible journey. I'm walking away from this deep dive with a whole new appreciation for my skeleton. It's not just a bunch of dry bones. It's this dynamic, living, moving system that makes all these amazing things possible. I'm feeling inspired to move my body, take care of my bones, and just marvel at the incredible design of it all.
I'm so glad to hear that. We often take our bodies for granted, but when we really stop to think about the complexity, the ingenuity of our skeletal system, it's truly awe-inspiring. It's a reminder that we're all walking around with these incredible, intricate machines inside of us, and it's up to us to take care of them.